Hi, this video we're going to look at an example of force along a line. So here is a tower and they have a guide wire connecting from A to B. They said tension is 2500 Newton. Then they said find components Fx, Y, Z of the force acting on the bolt A. So that gives us a sense of direction. So it starts at A, right? So it's a tension, so it's pulling. So from direction A to B. Then if we were trying to write down this force along a line, it's going to be F from A to B with a hat on it. They want us to find out each component. That's essentially a force along a line problem, because at the end you're going to write down this, right, in IJK form, and those will be our Fx, Y, Z. Okay, so knowing that, and they also ask the angles, and think about the angles theta x, theta y, theta z. That's going to be the beginning concept we learned. If you know Fx, and can you find that theta x? Remember, cosine theta x is equal to Fx over force magnitude. Yes, then we can. All right, so go ahead. Let's try to work on our first step. It's our position vector. Position vector is going to be from A to B, A to B. So in order to find the position vector AB, we needed to find AB coordinate. Then you figure out the coordinate difference. But sometimes when you get really fluent with this, you can just directly figure out the difference between those 2 points in terms of x and a yz coordinate, right? For example, from A to B, you know it's going to be final minus initial, B minus A. So what's the difference between B and A x coordinate difference? That's something you can consider. But before we do that, if you are thinking about coordinate, we have to have origin. We have to have a coordinate set up first. And this problem they haven't told us, but you can randomly, I said randomly, yes, you can choose arbitrary any coordinate system. Why? Because you're looking at the difference between those 2 points. So the relative distance is going to be the same regardless how you choose a coordinate. But here, there's a simple way to choose it. If we consider that's going to be origin. That's going to be our x coordinate. This is going to go up as y coordinate. This is going to be our z coordinate. And we're defining this force in orange color, right? That's going to be our force from A to B. All right, so knowing that, we can go ahead and write down our A coordinate. Since now we have a coordinate set up first, our x coordinate is going to be this distance, which is 40. How about our y coordinate? Y coordinate is how tall this is, right? And now let's see. Actually, I shouldn't draw like that, because where is our A located? A is located on the plane. A is on the XZ plane. If it is on that plane, the y coordinate will be 0, okay? So it's going to be 0. And in terms of z going forward is positive. Going back is negative. Obviously, A is behind origin, so it's going to be negative value. And it's how much behind? 30, negative 30. Okay? So now pause for a second, see if you can figure out the B coordinate by yourself. Okay, now let's be back. At B coordinate, what did you get on X? If you get down 0, that's right. Why? B is located on where? On this y-axis. If it is on y-axis, x gonna be 0, and so is 0. So is z gonna be 0. So only readout will be y. How tall is it? 80. So you have those 2 coordinates red. Then we just need to figure out position vector, final minus the initial, the coordinate difference. B minus A, 0 minus 40, negative 40I, 80 minus 0, 80J, 0 minus negative 30 plus 30K. And that's going to be our delta X coordinate difference, delta Y, and delta Z. Like I said earlier, in the future, when you get more fluent, you can rid of this step, finding the coordinate. You can just figure the difference between them. Now let's see. Between A and B, what is X coordinate difference? X is this direction. What is their coordinate difference? Should be this. That'd be 40. And what would be minus 40? Because from A to B, so B minus A. B is less number in terms of X, right? And A is higher number, so that's going to be negative 40. Now let's see. In terms of Y coordinate difference, from A to B, B is taller, so it's going to be positive value. How much taller? 80 meters above, so that's 80. Now let's look at Z coordinate difference. Z coordinate difference is B minus A. B is more in the positive direction. B is in front of A, so it's going to be positive number. How much more in front? 30. So plus 30. So start to thinking about it. Start thinking about the coordinate difference. That might, help solving the problem a little bit quicker. Now, next step is going to be the position vector magnitude, AB without a hat. And we know it's going to be, using Pythagorean theorem, negative 40 squared plus 80 squared plus 30 squared. That's going to give us the distance from A to B. And the answer we have here is 94.34, and that should have a unit of meter because it's distance from A to B. Knowing that now, we're going to find the lambda AB, the unit vector, which is AB position vector over the distance, right? And here I'm actually going to start to skip that step because you can. Because finally you want to get AB, the force. It's going to be the AB, the force magnitude, right? I'm sorry, this is wrong. Finally, you want to get this force along the line from A to B. It's going to be with a hat. It's going to be the force magnitude without a hat. Because magnitude has no direction, it's just a number. And then times the lambda AB. Lambda AB is position vector over AB, magnitude. So knowing that, we're actually going to combine step 3 and 4 together. Do we know the magnitude of this force? They said yes, it's 2,500 Newton. And now we also can put a direction here. Position vector, that's from our step 1 here. Negative 40I plus 80J plus 30K. Our position vector distance is 94.34. Then 2,500 times all that. Then we can go ahead, figure out our I, J, K term. Our I term will be 2,500 times negative 40, then divided by 94.34. Let's see what we have. Then we have negative 1060. 1060 for I. That's give us this I term. Same thing, you can figure out the J term. We'll have 2500 times 80, then divided by 94.34. That will give us 2120J. For the K term, 2500 times 30, then divided by 94.34, we'll have an answer of 795. Okay. So then you have your expression for this force along a line FAB in terms of IJK term. Then can we conclude our Fx is going to be equal to negative 1060 Newton, because this is in Newton, 2500 Newton. And our Fy is going to be 2120 Newton, and our Fz will be 795 Newton. Okay, so knowing those three forces now, very last one is a little bonus question. Can you find a theta x, theta y, theta z? Yes, we said theta x is going to be inverse cosine of fx over f. And for this problem, R is 1060 negative, and our F is 2500 Newton. That's the force you are decomposing. And let's see, what do we have? We'll have 1060 divided by 2500. Then we'll take inverse cosine of that. We'll have an answer as 115.09 degree. So we got your answer for theta x, and I will leave you up to solve theta y and theta z using the same concept. So that's all. So this is an example for force along a line, and I'll see you on the next one. Bye.